Elon Musk just put a number on the table that sounds almost fake. $122 billion. That is not a car. That is not a rocket. That is the price tag on a single chip factory called Terafab, and it might be the riskiest move Musk has ever made. Right now his personal net worth sits somewhere between $920 billion and $950 billion, boosted heavily by the recent merger of xAI with SpaceX and Tesla. And instead of sitting on that fortune, he is throwing a huge chunk of it at one goal: total control over the future of artificial intelligence. To understand how big $122 billion actually is, compare it to Bill Gates. That figure roughly matches, or even slightly beats, the entire lifetime fortune Gates built over decades running Microsoft. It is also close to the peak net worth of Nvidia's Jensen Huang, a man who basically owns the AI chip boom. According to CNBC and multiple other outlets, Terafab's full build-out is expected to land somewhere between $119 billion and $122 billion once every phase is finished. If those numbers hold up, this will not be just another factory. It could reshape who controls the entire technology stack, from cars to rockets to artificial intelligence itself. So what is actually going to happen inside Terafab, and why does it cost this much? People love to argue about Elon Musk, his tweets, his promises, his personality. But while the internet fights about him online, he keeps quietly stacking up an industrial empire that is hard to ignore. Giant EV plants on multiple continents, lithium refineries, battery megafactories, massive energy storage systems, the largest charging network on the planet, and now this, a chip manufacturing complex unlike anything the industry has seen. Terafab makes Gigafactory Texas look small by comparison. This is a joint effort between Tesla, SpaceX, xAI, and Intel, all under one roof in Texas, chasing a target that sounds almost impossible, producing something close to 50 times the world's current chip output. And Terafab is not just cranking out one type of chip. It is designed to build logic processors, high-bandwidth memory, and advanced chip packaging, all inside the same facility. No shipping unfinished silicon across 3 continents before it becomes a usable product. Every single stage happens in one place. The physical scale backs that up. The proposed complex is expected to cover about 100 million square feet, which is roughly the size of 1,700 football fields put together. Permit filings have already been submitted in Grimes County, Texas, and while the project is still in early stages, the stated goal is 1 terawatt of AI computing capacity every year, alongside somewhere between 100 billion and 200 billion custom chips annually. Intel officially climbed on board in April, and Tesla has been upfront about a big weakness: it has almost zero experience running a semiconductor fab. So the company went out and hired Gary Young, a manufacturing veteran with 17 years at Intel, to become Terafab's director, the very first official leadership hire for the project. Pulling in the person who ran Intel's advanced 18A manufacturing line sends a loud message. Tesla wants Intel's best people building its chip know-how from the inside, and that move could eventually give Terafab access to the 14A process node, one of the most advanced manufacturing standards the whole industry is racing toward. Most people hear Tesla and think electric cars. They hear SpaceX and think rockets. They hear xAI and think Grok. But dig a little deeper and one thing becomes obvious: every single one of these companies runs on the exact same resource, raw computing power. Right now Musk is reportedly spending at least 60 hours a week on 2 projects specifically, Optimus and Robotaxi. Both are close to mass production, and the real bottleneck is not the technology anymore, it is chip supply. Suppliers simply cannot deliver enough. A modern Tesla is no longer just a battery on wheels. Nearly every car rolling off the line runs autopilot and full self-driving, systems that lean on powerful onboard processors reading camera feeds in real time, spotting cars, pedestrians, signs, and lane markings. All of that runs through a single AI-5 chip, which Musk showed off at the Terafab launch event. Small fleets of cybercab Robotaxis are already testing on public roads, and Musk has said Tesla plans to roll out fully driverless fleets by the end of this year. Scaling that up means chip demand explodes. And self-driving cars are nothing compared to what comes next, Optimus. A humanoid robot has to do more than just see the world, it has to understand it instantly, balance itself, coordinate dozens of joints at once, and react to unpredictable situations on the fly. That takes an enormous amount of compute, arguably more than any smartphone or laptop ever needed. Then there is SpaceX and xAI stacking even more demand on top. It sounds strange that a rocket company needs cutting-edge AI chips, until you remember SpaceX runs Starlink, and reports suggest Musk wants to turn Starlink into an orbital supercomputer, a flying AI data center running reasoning models directly in space. That requires a completely new category of chip, something the industry has never mass-produced before. Then xAI pushes the compute race even further, because training frontier AI models now demands almost unthinkable numbers of GPUs and infrastructure, which is exactly why every major tech company is racing to lock down supply from Nvidia, TSMC, and Samsung. Based on Musk's own comments, he believes today's entire global chip manufacturing capacity might only cover around 2% of what Tesla, SpaceX, and xAI will eventually need combined. If that estimate is even close to accurate, this stops being a story about ordering more chips. It becomes a story about the global semiconductor industry simply not being able to keep pace with what Musk's companies want to build. Musk has floated the idea that Terafab could eventually hit 1 terawatt of computing capacity per year. That number sounds made up until you compare it to something real, the entire United States power grid, which averages around 0.5 terawatts. So if AI compute becomes the electricity of this era, Musk is talking about building digital infrastructure roughly twice the size of the country's entire power system. Break it down further, and if each AI chip burns around 250 watts, hitting 1 terawatt could require producing close to 4 billion chips every single year. At that point this stops being a car company side project and starts looking like the foundation of an entirely new industrial machine. Tesla knows how to build world-class electric vehicles. SpaceX knows how to launch rockets into orbit. But building cutting-edge semiconductors is a completely different sport. A 2-nanometer chip fab shares almost nothing with a car assembly line. It demands ultra-clean rooms, EUV lithography machines worth hundreds of millions of dollars each, atomic-level precision, and yields so tight that one tiny mistake can wipe out billions in investment. A single microscopic defect can ruin an entire batch of wafers. That is exactly why Intel matters here, decades of hard-earned fab experience that Musk cannot simply buy his way past with cash alone. At the center of Terafab's roadmap sit 2 flagship chip families, each built for a different piece of Musk's empire. The first is a new generation of AI processors, the brains behind full self-driving, Robotaxi, and Optimus. The AI-5 generation is expected to begin ramping this year before scaling into full production next year, with AI-6 and AI-7 already lined up to follow. Terafab could push Tesla's onboard computing power far beyond anything it has shipped so far. But the ambition does not stop on Earth. A separate chip family, the D3 lineup, is being engineered specifically for Starlink, built to survive radiation, brutal temperature swings, and the unforgiving vacuum of space. One chip family is optimized for split-second decisions here on the ground, the other is built purely for long-term reliability in orbit, 2 completely different engineering philosophies running under the same roof. The production numbers behind all of this are just as wild as everything else. Based on the current roadmap, Terafab could launch around 100,000 wafers a month, then scale toward 1 million wafers a month at full capacity. To put that in perspective, that level of output would sit somewhere close to 70% of TSMC's current total manufacturing capacity, from a company that has never run a chip fab before. And that raises the obvious question hanging over this entire project. How exactly does Elon Musk build a world-class semiconductor factory when none of his companies has ever operated one? That is not a small obstacle. Advanced chip manufacturing is widely considered harder than building batteries. A leading-edge fab needs ultra-clean environments, hundreds of millions of dollars in lithography equipment, an incredibly complex chemical supply chain, elite engineering talent, and precision measured at the atomic scale. Even giants like Intel and Samsung spent years refining their advanced production lines before hitting strong yields. To be fair, this is not the first time Tesla has walked into an industry everyone assumed was too hard to crack. When battery production became the biggest wall blocking EV scaling, Tesla did not wait around for suppliers. It partnered with Panasonic, absorbed years of manufacturing know-how, ramped production aggressively, and eventually built its own tech, including the 4680 battery. That decision became one of Tesla's biggest advantages over legacy automakers. But semiconductors are a different beast entirely, a much steeper mountain to climb, which is exactly why so many analysts are calling Terafab not just an ambitious side project, but potentially the single riskiest bet Elon Musk has ever placed. There is also a financial side to this that investors cannot ignore. Tesla's automotive revenue actually slipped last year, even as the company sat on tens of billions of dollars in cash reserves. Committing tens of billions more to a first construction phase, with the full build-out potentially reaching $122 billion, is not a decision Tesla is making lightly. Wall Street reaction has been split right down the middle. Some investors see Terafab as proof that Musk is finally solving the compute bottleneck holding back Robotaxi and Optimus, and stock sentiment has swung noticeably bullish on days when new details leak out. Others see a company already juggling EVs, energy storage, and robotics, now adding the most capital-intensive industry on the planet to its plate, all while automotive sales cool off. Skeptics point out that Terafab has no finished factory, no proven yield numbers, and no guarantee that any of the projected timelines survive contact with reality. Chip fabs are notorious for blowing past both budgets and schedules, and Musk himself has a long track record of announcing ambitious deadlines that slip by months or even years. Supporters counter that Tesla pulled off something similar with battery manufacturing, going from total dependence on outside suppliers to building some of its own most advanced battery tech in a matter of years. Whether Terafab follows that same playbook or turns into an expensive lesson in how hard chip manufacturing really is remains the biggest open question hanging over this entire project. Quick reminder before we keep going, if this kind of deep dive is your thing, smash that like button and make sure you are subscribed to Drive Tech Tesla, because Terafab is only getting started and there is a lot more coming. So where does this actually leave Tesla, SpaceX, and xAI? If Terafab delivers even close to what Musk is promising, it could hand his companies a level of chip independence no competitor currently has, faster iteration on AI5, i6, and AI7, tighter control over Robotaxi and Optimus production, and a real shot at powering Starlink's orbital compute ambitions without begging Nvidia or TSMC for allocation. But if it stumbles, and semiconductor history is full of ambitious projects that stumbled, Tesla could be staring down tens of billions in sunk cost during a stretch where automotive revenue is already under pressure. Either way, one thing is certain, Terafab is not a side bet anymore, it is now central to Musk's entire vision for where Tesla, SpaceX, and xAI go next. Keep this channel bookmarked, because as permits move forward and construction updates roll in, we will be tracking every single development. If you found this breakdown useful, hit subscribe, drop a like, and we will see you in the next one.